Hi, I'm Mr. Franklin, and in this video, I want to do a second quarter recap of our equation sheet and explain a couple things. In the first quarter, we are just learning physics processes, so we do some things with our equation sheet that we are trying to grow out of. And so our equation sheet, the nature of it changes as we get into quarter two. So I want to explain that a little bit in this video. So first thing I want to make it clear is to keep this simpler for people, we have divided the equation sheet into sections. So that was our first quarter, our first unit. Second unit, we've actually skipped this unit and we are now in the energy unit. We will hopefully get to talk about waves in a couple weeks, and then a couple weeks after that, get to talk about electricity. Now, what I want to point out is in the kinematics unit, this is generally the base equation that most physics teachers will teach you. And then from there, you have to do algebra. Now, since we are in a freshman level class, our math skills are not always that strong. So we have actually done the algebra for you. And so you have that equation, or you have that equation, and those are just the algebra worked out for you. So the algebra has already been done, and we give you those equations. But this equation is generally what most physics teachers will share as the base equation for velocity. Now, in the next unit, in the force unit, we do the same thing. So this is the general equation that most physics teachers teach. Okay, and then we already did the algebra for you. And so here are what the other two equations might look like. And that's because we know that your algebra skills a lot of times are not fully developed and you're still learning. And so we're just trying to help you do some of the math, but also focus on the physics that's involved, okay? That's been our whole goal this whole time, is what's the physics involved? But now you've had some time in your math class. You've had a quarter of math in your math class, as well as time in this class to get used to the process. And so now we've given you a single equation. We give you a single equation for power. We give you a single equation for work. We give you a single equation for potential energy. We give you a single equation for kinetic energy. And from there, you have to do your own algebra. Here's where it gets confusing and gets a little different depending on who you are. We did the algebra before you solve the problem, but what I'm teaching you is generally most people do better when they plug in the numbers and then solve for the algebra later. So we can talk about that, but generally what most people have a hard time with is which equation do I pick? So for example, this equation has work in it. This equation has work in it. How do I know if I see work, which equation to pick? This equation has a distance in it. We call it height, but this equation has a distance in it. Okay, so which equation do I pick? This equation has mass. This equation has mass. This equation technically has mass. Why? Because force equals ma. So we could actually do a substitution here. Okay, so it can get confusing real quick, and I don't know which one to pick. So let's take a look at a couple of examples and see if we can sort out how do I know which equation to pick. What we're going to do is we're going to look through each one of these and go to our equation sheet and decide which equation we should be using. Okay, so let's do this first one right here. Let's do this first one here, and let's just pick an equation. We're not going to actually solve it. We're just going to pick the equation. So I've got work, force, and distance. So I go to my equation sheet. And now I'm going to look at an equation that has force, work, and distance. Are there any other equations that have that set up? Nope. There's force, but there's no work, there's no distance, so it can't be that one. No forces over here. This is the only equation actually on this entire sheet that has work, force, and distance in one equation, so that's what I'm going to use. Okay, so let's switch back to our problem here. So I've got work equals force times distance, because I got distance, force, and work. So I have to look at this little table. This is why I make you make the table, is so that you can look up here at the table and figure out which equation to use. So then I'm going to go and then I'm going to plug in the numbers. So work is 20, force is 10, and the distance is missing. And now I can do algebra to solve for that. Okay. Some of you are plugging in the numbers because you're used to just plugging in numbers here. You got to follow what the variable is: work, force, and then distance. Okay. All right. So let's take a look at this one. Look at this next equation. And so we've got power, we've got work, and we've got time. So I go back to my equation sheet and I'm looking for an equation sheet that has power, work, and time, which happens to be this equation right here. Let's take a look. Are there any others that might do the job? Power, work, and time. Are there any others that might fit that process? There's a time, but there's no power and there's no work, so it can't be this one. Okay, so this is the only one that has all three variables. So the equation must be power equals work divided by time. And now it's a matter of substitution, but here's power. Don't just start plugging in numbers. Make sure you plug in the right number. Power is equal to 20, which is equal to work. Work is 10 joules divided by time. Okay, and so now you have your numbers plugged in, and now you can solve for your algebra. If you're not sure how to solve this one with algebra, I am going to do a separate video where I actually show how to solve this kind of a problem, where the variable is on the bottom of a fraction. Okay, so now let's take a look at this one. We got K, M, and V. Try it on your own. See if you can come up with what the correct equation is. K, M, and V. So pause the video and do it. Okay, welcome back. Let's take a look. Is this the equation you chose? So we have K, kinetic energy, we have mass, and V. So it's got to be that equation. Do we have any other equations with mass and velocity and K? We might look here, but there's none with mass in it in this column. Okay, and here we have mass, but we don't have K, and we don't have velocity. So it's got to be that equation. So the table is the secret to figuring out which equation to pick. This table right here that some of you have been refusing to do, that's why I've been making you do it, even though it seemed pointless at the time. This is why. So you could write the correct equation. K equals 1/2 mv squared. Okay, and now we can substitute. So K is 20 equals 1/2. M is 10, and then V squared. We don't know V, so we leave it as the variable. And now I can start working the math and solve for V. Okay, U and M and G and H, guess what the equation is? Should be UG equals MGH. And I say this every time, but I generally actually don't write the G, and I just put U equals MGH. How do I know that? Let's go look at our equation. I'm not just pulling that out of the table. I'm actually pulling that off the equation sheet. It's just I have the equation memorized. So the equation is potential energy due to gravity, that's what that means, equals mass times the acceleration due to gravity times height, MGH. So that's the equation you should use. The secret to using your equations and picking the right equation is a two-part secret. One, you've got to make the table and you've got to put the correct variables. You can't just like write the number. You got to write the variable equals the number with the unit. You've got to write it like that because that unlocks which equation do I pick. Because I got work, force, and distance. I got work, force, and distance. Power, work, and time. Power, work, and time. K, M and V. K, M and V squared. And then U, mg, h. U equals mgh. Okay. And just as a side note, like for example, I just realized that I did those in a pattern and I did not mean to. Let's say, for example, we had U equals 20 and we had H equals 10 and G equals negative 9.8. Then our unknown would be M. Then our equation would still be U equals mgh. So it's about what are the variables in the table, and that determines which equation we pick. Then the second key, the second secret is making sure you're plugging in the right number into the right spot in the equation. Don't just put in the number wherever you feel like it. Okay, so write the table, look at your table, at the variables, and find an equation with those variables. I think we've only given you one problem where we had extra information, okay? So be careful of that, but most of the time, whatever these variables are, you should be able to find an equation with all those variables present. The only other gotcha are problems like this with gravity, because we won't ever tell you that gravity is acting and you have to figure it out. And so that's where the picture comes in, because then you go, oh, it's falling and gravity's acting, so we must have little g. Okay? So pictures for hidden variables, make your table, and then select an equation, and then be careful when you substitute. Okay, that's kind of a recap and putting all the 7 steps in place. So far, they've been actually probably very easy for many of you, and you're like, why are we doing this? I don't need to do this. Well, now we're getting to the spot where you need to do this, and hopefully you have built up that habit pattern of just following the steps. Okay, and this is like baby step number 2. There's a baby step number 3 coming next week where we're going to add to this process. Okay, so make sure you're understanding how this flow works. Okay, that's all I've got. I could talk about this all day. So please make sure that you shoot me an email with any questions you might have, or any specific problems or questions that you have, so that I can address those more specifically. Thank you and have a good day.